2 videos ago, I told you that when you're dealing with an exponential function, that when you increase x by a constant amount, that the y values will increase by a constant factor. When we increased x from 0 to 1, we increased y by a factor of 1.5. We multiplied 1.5 times 120 to get 180. When we increased x by 1 again, once again, y increased by a factor of 1.5. We multiplied 1.5 times 180. What I want to do in this video is to kind of quickly show you, just going from the basic definition of an exponential function, why this is the case, why this works for exponential functions. So let's just start with the general exponential. Y is equal to a times r to the x. And let's look at some x values and then their corresponding y values. So these are my x values. Those are my y values over there. Now let's say that x is equal to, well, let me just pick an arbitrary number. Let's say that x is equal to b. I haven't used that variable yet. Then what's y going to be equal to? It's going to be equal to a times r to the bth power. Now, let's increase x by 1. This would also work if you increased x by really just a constant factor. But let's increase it by 1. So now we're going to look at x is equal to b plus 1. Then y is going to be equal to a times r to the b plus 1 power. Let's do it one more time. Let's increase x by 1. You get b plus 2. And now now y would be a times r to the b plus 2th power. Now let's see what happens when you take the ratio of each successive y terms that correspond to the x terms when you increase x by a constant factor. Notice every time we increased x by exactly 1. If this was 0, this is 1, this is 2. If this is negative 5, this would be negative 4, this would be negative 3. So let's see what happens with our y. So over here, if we look at the factor that y changed by, we could just divide a r to the b plus 1 by a r to the b. And what do we get? Well, you might already recognize you could use straight up exponent rules right here. The a's cancel out, and then this is going to be equal to r to the b plus 1 minus b. Same base, you're taking the quotient, you subtract the exponents. So this is just going to be equal to r. That's just going to be equal to r. Let's see what happens when we go from here to here. Once again, take the y value when x is equal to b plus 2. So a r to the b plus 2. Divide it by the previous y value. Divide it by a r to the b plus 1. These cancel out, and we're left with r to the b plus 2, r to the b plus 2 minus b plus 1, which is equal to r to the b plus 2 minus b minus 1. These cancel out, 2 minus 1. Once again, you're just left with r. So hopefully that satisfies any curiosity you might have had of why you're able to use that as the way to evaluate whether this data was exponential. Why we're able to just say, hey, let's take this term divided by the previous term and see what number we get. This term divided by that term. And if we get the same number every time, we're dealing with an exponential function.